So as I said before, the pitch is how high or low a sound is. So you can have a really high pitch or you can have a really low pitch. And so pitch is actually shown by frequency and wavelength. And so we can actually draw pitch. And so if I was going to draw waves, right? So I could draw a wave that looks like this. And I could go back to my less frequent wave that looks like this, right? So this one clearly has the higher frequency. Again, more waves, 1, 2, 3, 4, 5, 1, 2 in this one. The higher the frequency, the number of waves, you can see that there is a correlation between that and a shorter wavelength. So we can actually draw that in here and see this for ourselves. You can see that the wavelength is much shorter when you have a higher frequency. This also means that it has a high pitch. And I can do this actually. Pitch. I should just type it. All right. Also, it's a very high pitch. This one's going to have a very low pitch. All right. And going back to our vocabulary, that is what pitch is, and we have loudness. Now, loudness and pitch do not go hand in hand. Loudness is how intense a sound is, or how loud or soft a sound is, right? So if you have more energy, you have more amplitude, you have a greater sound or a bigger sound, a louder sound. And so we could show that, if we go back here, we can start a new one. We could show that by drawing two different types of waves. So if I have one that looks like this, and if I draw, and then I have one that looks like this, I could draw my rest position in the middle here, the line that goes through. Okay, and you could see that my amplitude from this point to this point is not very large, and it's much larger here. This one has a greater energy and therefore a greater amplitude, which means it's going to be a louder sound. This one up here has a smaller amplitude, less energy, and so it's going to be a softer sound. And so you need to be able to see those, and we're going to be looking at examples of these relationships in a second. And I do want to go back to just a few more of the flashcards, ones that we really didn't go over here, including, go back. So we have wave, energy. I want to talk about energy and what that means. So energy is the ability to do work, so the ability to do something. So when energy flows through a wave, it clearly allows the wave to move. So we're also going to talk about what a medium is. And a medium is going to be a material through which a wave can travel. So example, air, water. If I am speaking or singing and you are able to hear me with your ears, then my sound waves are actually traveling through the air. And we can diagram this by showing that. So if I have a blank sheet, and let's see if I can draw a wave. All right, so here's a wave. And actually, I'll replace it with that one. So here's a wave. And then let's say here, actually, let's use this bat. This bat, these are the sound waves that are coming from the bat right there, right? And those sound waves are going to be traveling through the air. So if my ear is here, it's not a very good ear, but let's say my ear is here. I can, oh, there we go. Look at that. I did not realize that was a capability. The bat's sound waves are going to be able to travel through the air to my ear, right? And so that's a really good example of a medium. The air would be the medium in this case. Mechanical waves or electromagnetic waves. Let's go back to our PS1. All right. And one last thing, how do they start? Waves start with a disturbance, right? So you have to send energy through something in order for it to start, and that begins with a vibration. So example, the tuning forks, when you did those in class, the tuning forks, you hit it against the rubber block, it starts to vibrate, sending the sound waves through the air, which is the medium. We're going to go on to video number 2 next on section 2, pitch, frequency, and wavelength.